Hello guys, today we will discuss some more problems. So he has given that in an RLC series circuit, the voltage across a resistor is 160 volts, an inductor is 240 volts, and total power consumed is 1000 watts. So he has given a voltage at 50 hertz is applied across the circuit. So he has asked to calculate the value of capacitor and also current flowing through the circuit. So we will draw the given data. So he has given RLC series circuit, no, resistor as well as inductor and capacitor. So here the voltage will be, voltage is 200 volts, 200 volts at 50 hertz, 200 volts and 50 hertz, and the voltage across resistor is 160 volts, and inductor is, voltage across inductor is 240 watts, 240 volts, and the power consumed also he has given, power consumed is 1000 watts, power consumed is 1000 watts. So he has asked to calculate the value of capacitor and as well as current flowing through the circuit. So he has asked to current as well as capacitor. This I am considering as L and this R. So the value of capacitor as well as current we have to calculate. So first we can write total voltage V equal to VR square plus VL minus VC whole square, VR square plus VL minus VC whole square. So the total voltage he has given as 200, and the voltage across resistor, the voltage across resistor is 160 volts plus VL voltage he has given, no, 240 minus VC voltage we has, so VC voltage he has given, he has not given, so we are considering it as unknown voltage VC. So from this I can take as 200 square equal to 160 square plus 240 minus VC whole square, 240 minus VC whole square. So from this I can subject VC value. So 240 minus VC, 240 minus VC whole square equal to 200 square minus 160 square. So 200 square it will be 40,000, and 160 square it will be 256. So the value of 240 minus VC whole square, the 240 minus VC equal to 120. So the VC value will be 120 volts. So the total, the voltage across capacitor value will be 120 volts. Next, so he has asked to calculate the current, no? So from this tan pi we can consider that tan pi equal to VL minus VC by R, no, VR. So VL value is 240 and VC value is 120 by resistor, the voltage across resistor value is 160 volts, 160 volts. So the tan pi equal to the value will be 120 by 160, 120 by 160. So the tan pi value will be 120 by 160. So the pi equal to tan inverse, no? So pi equal to tan inverse of 12 by 16, 12 by 16. So the pi value will be 36.86 degrees, pi equal to 36.86 degrees. This is the pi value. From this we can calculate the current, no? So power equal to VI cos pi, VI cos pi. So the power he has given as the value as 1000 watts, and the voltage value is 200, and the current value we are calculated cos of pi value 36.86. So from this I can subject the current value will be 6.25 amperes, current value will be 6.25 amperes. This is the current value. And he also asked to calculate the capacitor value. So for the capacitor value, as you know, voltage across capacitor VC equal to I into XC. I into XC. So I into omega C, no? I into 1 by omega C. So I can write omega value as 2 pi f, no? So I by 2 pi fc. I by 2 pi fc. So that I can write I by 2 pi fc. So this is the voltage across capacitor. So if I subject the C value here, as you want to know the calculation of C, so C equal to I by 2 pi f into Vc. 2 pi f into Vc. So from this we can calculate the C value. C value will be 165 microfarad. C value will be 165 microfarad. On substituting all the values, the C value will be 165 microfarad. So as we calculated the current value as 6.25 amperes and the capacitor is 165 microfarad for the series RLC circuit. So two values we have calculated. Thank you guys. We will meet in next class. Thank you.